Hey, this is Neil's on Dynasty. Please like, share, and subscribe. Be kind, helpful, and grateful. Or Miss Chloe will run by you and look at you, wonder why she ran by you. And buy some silver, some platinum, and some crystallized osmium. Because Dixie, Miss Love Bunny, don't trip me. What's up there? No, that's not what this is about. Get out of my way, Chloe. This is about something even more interesting than Neil's cats. How can that be? Is there anything more interesting than my cats? Oh, this. After. I have to say this. After 5 years of the Northern California fires burning everything down to the ground, and it being made illegal for the towns to rebuild because of the fire, and they don't want to pay the insurance to rebuild the towns, but yet Southern California can burn and the whole world will pay for it. Why is Southern California more important than the people who burn in Northern California? I don't understand that. Maybe we're a subclass of Californian or something. But anyhow, regardless, we still have all the water. So if Southern California's stealing it from us. This is interesting. Interesting.
First, live, local. This is Fox 12 Now.
Hello, everyone. This is Fox 12 Now. I am Greg Nibbler. We appreciate you joining us. We are live streaming here out of the Fox 12 Oregon newsroom, as we do every weekday, starting around 1 p.m., going throughout the afternoon. I just want to remind you, we're on our YouTube channel. We're at kptv.com, and we're under the Fox 12 Oregon app, so you can find on pretty much any device. Right now, we are talking about an aquifer that was discovered in the Cascades, east of Eugene, there in the Central Cascades, that is estimated to be...
Eugene is California, Northern California, where I'm at. You know, the place that burns down and no one cares about?
3 times the size of Lake Mead. We're going to get into that.
California just discovered in the Cascades an aquifer 3 times the size of Lake Mead after Southern California burns. After Northern California burns, we discover we had the water to put it out. All those fires. We have so much water. We have water here. We have water there. But we have to burn you out before we discover it. No, they knew about this.
And discuss what an aquifer is, how it was discovered, what this could mean, and all of that right now with Leif Karlstrom, U of O earth scientist, who is joining us right now, who is part of this amazing discovery and research that was going on. Leif, thanks for joining us here today. Really appreciate it. And I think to start off, would you mind just giving everybody a basic definition of what an aquifer is, in case they don't know?
Bounds from one doctor to the next.
Yeah, thanks for having me. An aquifer we can think of very simply as just a large reservoir of water stored in the ground. It's a water resource. When we turn on our taps, that water comes from somewhere. And if you live in the Willamette Valley or in the Deschutes watershed, that water is most likely coming from the Cascades. And so that's the study area that we're focusing on.
Coming from aquifers that are there in the Cascades, those are refilled by, I assume, snow melt, rainwater, all of that, and then filtered through the ground there.
Absolutely, yeah. So it's a renewable resource, but it is dependent on there being precipitation and dominantly snowpack in the Cascades. Yeah.
And can you tell us about your study and how you came about, going about this study that ended up discovering this particular aquifer?
Yeah. So actually, it's a bit of a circuitous story in some sense. I'm a volcanologist.
Hold on. He's a volcanologist. Funny. Neil has been doing reports on volcanology for the past couple weeks. It's amazing that now a volcanologist comes out and tells us about the largest aquifer discovered 3 times Lake Mead. Makes you wonder if Neil and I might know something before the news people come out with this stuff, because I did preemptive stories letting you guys know about volcanism, the importance of volcanism in this planet. And now a volcanist discovers the largest aquifer in America.
Normally, so I study how volcanoes work, how they repave the landscape, and of course the Cascade Mountains are a volcanic mountain range. And so in studying the long-term history of these volcanoes, we sort of realized that there's potential to use the type of data that we use to study volcanoes to inform groundwater resources. And so it's sort of an indirect way towards this science goal. But once we realized that we could learn something new and we had a new tool to probe the dynamics and size of this reservoir, that led us to where we are now.
Is there something particular about volcanic mountain ranges and volcanoes in general that lend themselves to be more prone to aquifers and bigger aquifers like this?
Yeah, so it's the geologic properties of the rocks, right? Their fracture density, their porosity, these sorts of things that determine how much water can be stored underground, and then how fast that water can move when it's stored there. And especially
basically, to make it simpler, volcanic tubes that shoot the lava through. They shoot the lava through, then they're just a big tube. These big, and another thing, they've got these domes underground that filled with lava, so that when they shoot the lava out through all these tubes, wherever they go, that's what causes volcanoes, or causes earthquakes as well. And then sometimes it causes volcanoes. They get rid of all of that lava in those tubes that they make and in their reservoir of lava, leaving open space. Gravity being what it is, with the earthquakes happening around the volcanism or where the lava is, it causes cracks. Water comes down, fills them. That's where you get steam fissures that have just shown up. I just did a report on it. I don't know where they were showing up, somewhere in Indonesia, I think. No, maybe I didn't do a report on that. Yes, there's some steam vents popping up in the Indonesian area from this exact same thing happening. Water. They were talking about the ground raising up from volcanism, then going back down, leaving a void. Water was coming down, hitting it. It was still hot, so it was causing steam, making basically like Yellowstone with your geysers, but on a very small scale. That is what happens if you become knowledgeable about the Earth and actually a little bit about everything. Things really fit together perfectly, because you're like, oh yeah, there's a hole left there. Water will fall in. Yeah. It's real simple, actually.
Relatively recently erupted lavas, and by relative I mean in the last million years or so. So we call that young, geologically speaking. Those rocks tend to be very highly fractured and highly permeable, and so make great aquifers.
And so when that water's flowing through there, I mentioned earlier, but I mean that's filtering that water. Is that correct?
Yeah, that's right. Yeah. So I mean, there is a pathway that generally takes. We actually have some constraints on this, because this I'm not the first one to study this by any means, right? So this groundwater system has been studied by others, and we estimate that it takes anywhere from sort of 7 to 10 years upwards to greater than 1,000 years for water to pass from the recharge zone up high to springs and streams down below where we measure it.
So saying that, that snowpack there at the top of the Cascades, just for an example, for that to filter through down to those springs and some of those streams that we're used to seeing, anywhere from 7 years to 1,000 years. Is that correct?
Or more. We can think about the pathway that a water particle takes as highly dependent on where it enters and then the structure of the rocks, right? So some water particles transit the system very rapidly. Others take a much longer route. And so it's many of those together that make up the water that we see.
And tell us about this particular aquifer, the study of, I guess, how you went about discovering this.
Yeah, well, so first I should say that we didn't discover this aquifer, first of all. So it's been around. In fact, the estimate related to Lake Mead has been posed before.
Okay.
But we're expanding this considerably. I think previously the number was about 1 times the size of Lake Mead, or in absolute numbers, that's about 30 cubic kilometers metric system, I suppose. But what we did is we're able to use old exploration drill holes primarily to make this new estimate that in the 70s and 80s, there was a lot of interest in geothermal in the Cascades. And so there was a whole sequence of drill holes that were drilled, some of them quite deeply, over a kilometer. And those fingerprint the active groundwater system, because the temperatures that they discovered in those drill holes were essentially constant. So normally you expect rocks to heat up as you get deeper into the earth, and this just wasn't the case for the Cascades. And in fact, as you drill deeper, sometimes the temperature went down, got colder, which seems very strange. But you can explain that through the movement of heat by groundwater. And so when you see these sort of unusual temperature profiles in the drill holes, that's a fingerprint for actively circulating groundwater. And so we sort of interpolated, we sort of combined all these drill holes to get a sense of the volume that's involved here.
And so you were able to do that and correlate all of that data and then determine that this could be up to this size.
Yeah, and I should say, we've tried to be pretty conservative with this estimate.
Conservative. Okay, basic bottom line is we don't live on a dead rock. We live on what's known as a living planet, meaning the ecosystem. I know it's hard to believe its name is not called Frank or Nancy, and it doesn't have a heartbeat, and it doesn't have blood running through it. You got to look at life in several different mannerisms. A living planet means everything is happening. Volcanism, earthquakes, and rain all create not only drinking water, but streams and aquifers. It's a process of an evolutionary living organism that we call Earth. It is actually a living organism. I won't get into it. Anyhow, you guys have a nice night. Bye.